This is a discussion on the role adrenaline and insulin plays in our stress regulation, especially as it relates to blood sugar. There's an accompanying chart that you need to follow to really make sense, and we'll just kind of go through the chart. Stress, as it enters our body, goes through the HPA axis, and it arrives to the adrenal glands from the hypothalamus and the pituitary. From this point on, in the adrenal cortex, it makes cortisol. Cortisol is an anti-inflammatory and stress hormone of the body. That's the primary one. It basically produces a high blood sugar through a variety of mechanisms, gluconeogenesis, for example. When stress signals hit the adrenal medulla, the adrenaline, which is also called epinephrine, and is part of the catecholamine family, is released. Now, adrenaline is a very special hormone. It circulates around the body, as we all know. It is part of the fight or flight process and the body's defense mechanism. We all know, with the fight or flight, the response include heart palpitations or constriction of blood vessels, but it can lead to a lot of dysregulation because adrenaline is the ultimate powerful anti-stress and the last resort that the body has to fight stress. So the primary goal of adrenaline is to push more sugar into the blood, and so that the sugar can go to the brain for function. So the way it does that is to increase our heart pumping action. It will increase blood flow to the brain, but it will reduce kidney blood flow. It will reduce the GI blood flow, for example. And these have been all well researched. Excessive adrenaline, can have problems, and we'll go into that later. But the most important right now we have to kind of appreciate is that the flow of the adrenaline is, number one, is to support the survival. And in order to do that, it has to bring sugar into the system. So by way of gluconeogenesis, which is conversion of protein into sugar, as well as glycolysis, which is the conversion of glycogen, which is a storage factory of sugar. When it's not being used, it will convert also that into sugar. And so ultimately, between cortisol that raises the sugar and the adrenaline that raises the sugar, the body has enough sugar to keep the brain going. Of course, when you're under stress, there's a tendency to be have more hunger, for example. And as a result of that, the body tends to eat more, and hopefully that will bring in more sugar as well. So in this process, the body has this survival mechanism pretty well planned out. And so this is what the body does. Okay. Now, let's look a little deeper. From the increase in blood sugar, what happens, the next step, is that sugar in the body is controlled by insulin. Insulin's reaction or action is to push the sugar into the cells in order to reduce the blood sugar in the bloodstream, but increase sugar in the fat cells, especially for ATP mitochondrial functions, for us to run away from stress, and in the case of the brain, to give us some more alertness and focus. Now, increase in insulin will then, under normal circumstances, will reduce the high blood sugar that is caused by adrenaline back down to normal. And this usually is a very short period of time, maybe a few minutes or at most a few hours. It's designed to help us survive, and then the moment that the stress is gone, the adrenaline should reduce and the insulin output will reduce as well. This is the way it's designed. Now, in the modern society, because of chronic stress, we don't see the acute physical stress of running away. The situation is quite different. So in normal situations, the sugar is pushed from the bloodstream into the fat cells. And when that is done, then the insulin goes down, the blood sugar goes down as well, because it's being shunted into the fat cell, and we go on our life. Now, if the insulin secretion is too much, what happens is that the blood sugar becomes too low. Remember, the sugar is being pushed into the cell, the fat cells. And this may not show up in terms of absolute hypoglycemia, because the blood sugar may still be 70, 80, or 90, but relative to what it used to be or regular to normal, it is low. So the body has these subclinical hypoglycemia events that happen, and sometimes it can go down low. And oftentimes this happens after a meal, especially people report what is known as a food coma. Especially at 3 or 4 afternoon, when you eat at 1 o'clock, the sugar hits the gastric system, but then for 45 to 90 minutes. In fact, it hit it right away, but it hits a peak. Depends on how you eat, etc. And the insulin comes out from your pancreas. And if you have normal insulin, the postprandial hit the peak 1 to 2 hours, and then things kind of fall back down. If the insulin is too much, then the blood sugar can be low. Okay, it may not be absolutely low, but it will just be low on a relative basis. Now, the body reacts. Now, and everybody is different. And how does the body react? The body reacts thinking that, well, blood sugar is low, so I must be in danger. So there's a feedback loop into the adrenaline and into the adrenal medulla to ask it to put out more adrenaline. So if the insulin comes out too much, the blood sugar becomes low, adrenaline output will increase. So this is a vicious cycle, isn't it? The adrenaline increase blood sugar, which causes the insulin to come up, which causes the blood sugar to go down, which causes more adrenaline to come up from the adrenal to stimulate the pancreas to make more insulin. So the cycles kind of repeat and keep going on and on and on. Well, so this means what? That means that if you have a person that is making a lot of insulin, their adrenaline is going to be chronically high. So that is very important, because that means that your blood sugar is always being struggled. The body's blood sugar is high from adrenaline. Also, it can be high from cortisol, because cortisol also generate high sugar. And if you eat a meal that is a donut and you have a high carbohydrate meal or a high glycemic index meal, that also increases blood sugar. So, if you're under stress, the cortisol leads to high sugar. You eat more food, you eat more donuts, there's more sugar. Adrenaline, you have more sugar. So the whole body is flooded with sugar by design. But when this go haywire, that's the problem. Now, let us look further into what it means when it means that there is too much insulin. Now, when the body is making so much insulin, most of the sugar is being pushed into the fat cells. Well, the fat cells are all over the place, including in the liver. And excessive sugar is stored inside the fat cells. But the fat cell has a storage capacity. The organ has a storage capacity. So, for example, the liver is store excessive sugar as fat in the form of triglyceride, for example. And of course, peripheral fat cell also has their own limit. And if you reach that limit of sugar storage, well, what happens is that it's almost like you have a hotel that the rooms are now full. There's no more room left. So if you have extra gas coming in, and the insulin is working very hard to push the gas into the hotel, or the sugar into the fat cells, the sugar cannot get in. So in the case of the liver, it will convert into triglyceride. For example, you will have fatty liver, for example, and you end up with syndrome X, with hypertension, high triglyceride, low HDL. But in the rest of the body, including the liver, this sugar has nowhere to go. So it spills back into the bloodstream. So as a result, you have high blood sugar. So the high blood sugar, the common conception, and it may be right to a certain degree, but it's not the total picture. It's commonly understood as insulin resistance, meaning the cells are resisting the insulin. But nobody ever think about, well, the insulin is actually working too well. As a result, the sugar is reached the capacity in terms of storage and nowhere to go. And so this is a very fundamental change in the concept we understand about onset diabetes. The treatments are very, very different. If you keep giving insulin or enhancing drugs to enhance insulin action, you're just basically pushing more sugar into the fat if you don't change the diet. So even the best diet, if you have insulin resistant concept and you give insulin, eventually fail. And the risk of mortality does not really go down. So the only way you can really help this process, if it's a diabetes, for example, is a low-carb diet where you reduce the food intake of high glycemic food. You force the body into somewhat burning protein and fat instead of carbohydrates. But in terms of the insulin as it relates to stress, you can see now that cortisol, adrenaline, and insulin, these three play a very significant role in how the body modulates stress. A lot of people with stress will eventually have diabetes. A lot of people with stress with high adrenaline mode as a baseline. Well, in addition to what we talked about, the insulin complications from high adrenaline can also lead to the fight or flight response, which either can lead to heart palpitations, atrial fibrillation, PVCs in the brain, triggers ADD peripherally. It causes attention deficit syndrome plus hypertension. It have generalized anxiety disorder such as OCD, PTSD. We're going through the list. The muscles is tense when you have adrenaline that is in high amount. So what happened? The muscle is always fibrillating, especially the small muscle. Sometimes people will feel their eyelids are twitching. The tense muscle that become fatigued. The lactic acid build up, and you can have fibromyalgia. If the lactic acid build up in the bladder, it can lead to interstitial cystitis, for example. Other symptoms of adrenaline high includes a restless leg, headaches of unknown origin, urinary incontinence, bad wetting, chronic interstitial cystitis we talked about, road rage. So there's a host of things, and some people are even tying in some form of autism and a chronic cough into this whole adrenaline issue. In summary, adrenaline, when it's high, is a big problem. Now, we know that the adrenal glands has the dual mechanism of helping us put up the stress. In the neuroendometabolic model thesis, we know there are 6 circuits that modulate how the body deals with stress. And cortisol is one of the main functions, and through the HPA axis, and we have to deal with that. If you deal with the cortisol, you don't deal with the adrenaline, is a problem, because at the tail end, when the cortisol compensation is reaching its max, then the adrenaline takes over. And adrenaline is the ultimate in control. But the sequelae of high adrenaline leading to high insulin eventually can lead to sugar imbalance and adult onset diabetes. So if you look at a person that is a high stress of diabetes, and they may have been internalizing a lot of emotions, they may look okay, they may be underweight, they may be normal weight, they may be overweight. A lot of people think of AODM, adult onset diabetes, is overweight, and that is correct because that is the food component. But there are also a lot of skinny people that also have diabetes. So how do you explain that? You see? So, in addition to the some insulin resistance, which I'm sure happens to a lot of cases, there is the separate component of excessive insulin production in the body that's never quite fully recognized or appreciated. So we really have to study that, and it's all tied in. That the bottom line is, if you really take care of the adrenals, you make sure the cortisol is well under control, you don't have the reactive type hypoglycemia or hypoglycemia period from high insulin, then the adrenaline output will go down. When the adrenaline output goes down, the whole body settles down, and you don't have the excessive spillover. Your liver is better, your triglyceride goes down, and your HDL will actually go up. You don't have the fatty liver. So these are all part of the clinical picture. And then, of course, the body will be more calm. You sleep better, the muscle tenseness goes away, you don't have fatigue. And so, you start with the adrenals and appreciate all the connections, I think you have a good handle. There are a lot of supplements that we can use to help this process. We have the cortisol supplement, which is the adrenal, vitamin C, for example, the Pandrenal, which is the vitamin B5. You have the glutathione to make sure the liver is very well taken care of. It's very important because adrenaline has to be broken down. And, these cofactors as well, such as vitamin C and glutathione, are very, very important. You can calm the body down with medications in extreme cases, but a lot of times the progesterone can be used in men and in female. It settles down the brain. It helps with the neurotransmitter function. It increases inhibitory neurotransmitters such as GABA, and also reduces the effect of the hypoglycemia reaction from excessive insulin on the adrenaline output. So between the combination of all these items, it works wonderful, and the results can be quite dramatic. The progesterone use has to be not by mouth. It has to be by cream in the high blood flow areas, such as the inner arms or the neck, especially for those people with headaches and tinnitus. The neck is a better area, but you have to do it 1 to 3 minutes or 5 minutes right before a meal. And then it will have that instant effect because progesterone in the bloodstream doesn't last too long. So it offsets the insulin effect. That's what it does. At the central area, it takes a little longer, and that's why you can do it at night as well. But if you do eat a snack at night, then you can do a little progesterone before you snack. But generally speaking, for breakfast, lunch, and dinner, for those people who are on that schedule, do it right before you eat. It's very important to follow that. It's no use to do it too far ahead. Then you're just getting the estrogen dominant repelling effect and neutralizing effect, and not so much a adrenaline reduction effect. I hope this helps you. This is a very interesting topic, seldomly addressed, but as clinicians, we see this quite often. So don't be afraid to use some of these tools. Of course, the progesterone you have to be, there's some controversy, especially with people with breast cancer, if they are progesterone positive, whether it is safe. The conventional medicine will tell you that it is unsafe, but we don't find that clinically to be quite significant. Also, because of dosage, it varies from person to person. Use that as a gauge more so than the lab numbers, okay? And then we just have to go step by step. You can, for the people who are already in a very, very advanced adrenal fatigue, their body can be quite sensitive. So you can have paradoxical reactions for reasons we don't quite understand. You can have a estrogenic effect, which can happen in even normal people. So these are things you have to watch out for. I give you a general picture of the importance of adrenaline control. Of course, you can always use adrenal breathing to help with reducing sympathetic tone. Adrenaline, when it's high, is also called adrenaline dominant. We use the term reactive sympathetic reaction, and we are saying the same thing, okay? So because the catecholamine family of hormones and neurotransmitters starts from dopamine at the top level, it goes down to norepinephrine as the daughter chemically, and then it goes down to epinephrine, okay? So the mother of dopamine is actually tyrosine, the amino acid. So these are very, very strong, okay? So it gets stronger as it goes down the cascade, and it's weaker as you go up, so to say. So if you're in the ER and your blood pressure fell off the cliff, then you'll be given dopamine, for example. In adrenal fatigue, we see this all the time. When the cortisol finally gave out, the adrenaline and the norepinephrine, this chemical mother, basically come to the service. So when you have a lot of norepinephrine, you can have this heart throbbing, you feel this pumping, and for no good reason, you can have tinnitus, you can have a breathlessness when you go up a flight of steps. And if you have to, because of these catecholamines, they convert, norepinephrine is released in the brain, and it circulates in the brain. It's like an amphetamine. It causes anxiety and irritation, and it goes down to the heart and causes, as I said, throbbing and palpitations. But if you have too much, then some of it's going to convert into adrenaline or epinephrine, And that is what causes the heart fast rate, for example, and then the PVCs, and ultimately can be in atrial fib. So this cascade of neurotransmitters and neurotransmitter and hormone in the case of norepinephrine, and hormone in the case of epinephrine released from the renal medulla has significant wide-ranging effect. It's not so simple as what most people think. And also, okay, for most people, if it's a chronic, if it's an acute thing, come and go. Everybody has stress or a car accident. But if it's chronic, and this will just eat up your body over time.